Welcome to the deep dive. You're here because you need to get the real story on complex tech fast without getting lost in the weeds.
Yeah, we're here to cut through that noise.
So think of this as your shortcut to understand what actually matters. Today, we're diving into something pretty big in virtualization. Proxmox VE now supports NVIDIA vGPU.
Exactly. And that's a game changer, really. It opens up a whole lot for GPU acceleration, but shared across different virtual machines.
Okay, so let's just quickly define vGPU for anyone maybe not totally familiar. It's basically chopping up a physical GPU, the cores, the memory.
You partition its resources, so multiple VMs get a piece. They sort of take turns using the main GPU engine, and each gets its own slice of the video memory.
Right, so instead of one VM hogging a powerful card, maybe not even using it fully.
You share it, much smarter use of the hardware, especially those expensive high-end cards. It just maximizes the potential.
Makes sense. So that leads to the big question. Why should people care? Why is this vGPU support in Proxmox VE actually a big deal?
Well, think about the workloads that need GPU power. High-end rendering, for instance.
Yeah, stuff that takes ages.
Right. Now you could potentially have several VMs working on parts of it using that shared GPU acceleration. Or think about VDI, virtual desktop infrastructure.
Ah, laggy virtual desktops, the
Right.
bane of existence for some.
Exactly. vGPU can make that experience way smoother.
Yeah.
Much more like using a local machine with a decent graphics card. And then there's AI and machine learning.
Huge. Everyone's talking about AI.
And it absolutely chews through GPU power. vGPU makes that power more accessible, more flexible within your virtual setup. You can spin up VMs with GPU access when you need them.
So the common thread here is sharing, right? Sharing one powerful, probably expensive GPU instead of needing, I don't know, multiple cards.
Precisely. It's about efficiency. Better hardware utilization, which can mean serious cost savings. You don't need a dedicated GPU for every single VM that needs some acceleration. Plus, you can pack more into your servers. Density.
Okay, sounds great. But how easy is it? It's not just a checkbox in Proxmox, I'm guessing. What do you actually need to get this going?
No, definitely not just a checkbox. There are several key things you need first. Prerequisites.
Lay 'em on us.
Okay, first up, the NVIDIA vGPU software itself. It's commercial software, so you likely need to purchase licenses, though sometimes they offer evaluation versions.
Okay, software license. And you need an account with NVIDIA.
Yep, an NVIDIA Enterprise account. That's where you download the software and manage the licenses.
Right. What about the graphics card itself? Any NVIDIA card works.
No. That's important. You need a specific vGPU-compatible NVIDIA card.
Yeah.
The source we looked at, they were using an NVIDIA L40S. So you absolutely have to check if your card model supports the vGPU feature set.
Got it. Specific hardware required. What else? Drivers, I assume?
Oh yeah, drivers are critical, and very specific ones. You need the Linux KVM drivers from NVIDIA's portal. The versions mentioned in the source were, let me see, vGPU software 18.0 overall. Then the host driver was 576.4.124.03, the Linux guest driver 570.124.06, and the Windows guest driver 572.60. Keeping those versions aligned is really important for stability.
Wow, okay. Specific versions, note to self. Check the documentation carefully. What about managing the licenses once you have them? How does the VM know it's allowed to use a vGPU?
Good question. You need a license server, either a dedicated one you set up yourself, that's the DLS, dedicated license server, or you can use NVIDIA's cloud license server, the CLS.
Okay, so a central point for license management.
Exactly. The VMs need to check in with that server to activate their vGPU. NVIDIA has guides, like a quick start guide mentioned in the source, on setting those up. It's a necessary step.
Right, so software, account, compatible card, specific drivers, license server, anything else on the server side, like in the BIOS or UEFI.
Yes, absolutely. This is crucial and sometimes tricky. You need to dive into your server's UEFI settings.
Fun times.
Yeah. You need to make sure things like VTD or AMDV are enabled. That's the basic hardware virtualization support. Then, SR-IOV. Single root I/O virtualization. Very important for vGPU. We'll touch on why later. Also, above 4G decoding and resizable bar should be enabled if available.
Okay.
And one more, alternative routing ID interpretation, or ARI. But fair warning, you might not see all of these options listed in every server's BIOS menu. Depends on the manufacturer.
Good to know. Might need some digging. And finally, Proxmox itself. Any specific version needed?
Yes. You need Proxmox VE PV Manager version 8.3.4 or newer, and the kernel needs to be 6 0.1.12 APVE or later one.
Okay, how do you check that easily?
Just go to your Proxmox node in the web interface, click on it, and look at the summary tab. It lists the manager version and the kernel version right there. Always check that first.
Phew. Okay, that's quite the checklist. So assuming someone's done all that prep work, now what? How do you actually configure the Proxmox host?
Right, now we get to the setup on the host itself. You use the Proxmox web interface, select your server node, and open the shell.
Command line time.
Yep. First command is apt install pve-nvidia vGPU helper. This installs a helper tool Proxmox provides to make things a bit easier.
A helper tool. Sounds good. What does it help with?
It automates some of the initial configuration steps. So after you install it, you run it. pve-nvidia vGPU helper setup.
Okay.
It'll probably ask you to confirm some things, just answer why and proceed.
Uh-huh.
And once that script finishes,
Let me guess. Reboot.
you got it. Reboot the Proxmox VE server to make sure all the changes stick.
The classic solution. All right, server's back up. What's next?
Now you need the NVIDIA host driver file, that .run file you downloaded earlier onto the server. Usually you'd use something like SCP or SSH to copy it into the home directory.
And you mentioned it might be zipped.
Yeah, good point. The download from NVIDIA might be a zip archive, so you might have to unzip it first and find the .run file inside a folder, maybe called host drivers or something similar.
Okay, so file transferred to home. How do we install it?
Back in the shell. First, cd home to get into the directory. Then, change ownership.chown. To root your driver file name .run, you need to replace your driver file name .run with the actual file name, of course.
Uh-huh. Use else if you forgot the name.
Exactly. Then make it executable. chmoud plus x your driver file name .run.
Okay, owner set, executable set. Now run it.
Yep. Your driver file name .run, DKMS. Again, use the correct file name. The DKMS part is important. It helps the driver rebuild automatically if you update your Linux kernel later. Save some headaches.
Ah, DKMS. Good tip. Okay, driver installed. What about that SRIOV thing we mentioned earlier?
Now's the time. SRIOV basically lets the physical GPU pretend to be multiple virtual devices.
Right.
That's how vGPU works underneath. You enable it with systemtitle enable now pve-nvidia-reoff at allel.service.
Enable now, so it starts right away and also on next boot.
Correct. Enables and starts the service for all compatible devices.
Okay. SRIOV is running. Are we done with the host setup yet? Almost.
Almost. Final host step is back in the Proxmox web interface. Go to Data Center View, then the Resource Mappings tab.
Resource mappings. Okay.
Under PCI devices, click Add. Now you configure the mapping. Gives a clear name you'll recognize like NVIDIA L40S mapping or whatever.
Makes sense.
Crucially, check the box. Use with mediated devices. Make sure the right Proxmox node is selected under Mapping on Node.
Mediated devices. Got it.
Then you'll see a list of PCI devices. Look for your NVIDIA GPU, check the vendor column, select the NVIDIA device. If you only have one NVIDIA card, you might just check the box at the top. If you have multiple cards,
Use else PI in the shell to figure out which is which.
exactly. Use else PI to identify the right one. If needed, select them, then click Create, and that completes the host setup. The GPU is now ready to be carved up.
Nice. Okay, host is ready. Now the fun part, giving a VM some of that vGPU power. How do we do that?
All right, pick your VM. It needs to be fully shut down first. Can't do this live.
Okay, VM powered off.
Go to its Hardware tab, click Add, then choose PCI device.
Familiar territory. What do we pick in the Add PCI device window?
In the Device dropdown, you should now see the resource mapping name you created earlier. Select that.
Ah, okay. That links it to the physical card setup.
Precisely. Then you'll see the MDEV type field. This is where you choose the specific vGPU profile.
Right, you mentioned those before. The ones with numbers and letters like 12Q. What do they mean again?
So the number is usually the amount of VRAM in gigabytes that this VM will get. 12Q means 12 GB. The letter Q, B, or A tells you the intended use case and the license needed.
Okay.
Q is typically for virtual workstations, needs an RTX VWS license. B is more for virtual desktops, uses NVIDIA Virtual PC or VWS licenses. A is for virtual applications, needs the virtual applications license. NVIDIA has docs detailing all the profiles.
So you pick the profile based on VRAM needed, the job the VM will do, and the license you have. The article used NVIDIA L40S 12Q.
Right, so they gave that VM 12 GB of VRAM for a virtual workstation workload. After selecting the MDEV type, make sure to check the PCI Express box.
Why that box?
Ensures it shows up to the VM as a proper high-speed PCI device. Then just click Add.
Okay, so Proxmox now knows the VM should have this vGPU slice. Is the VM ready to go now? Start up and magic.
Not quite magic yet. The VM's operating system needs the driver too. So power on the VM. You need to install the NVIDIA vGPU guest driver inside the VM's OS.
Ah, Ah, right, the guest driver we downloaded earlier.
Yep, get that file onto the VM, run the installer just like any other driver.
Okay, guest driver installed, then the license activation.
Exactly. This is where your license server, DLS or CLS, comes in. You need to configure the VM to talk to it. The source mentioned using a cloud license server and putting a token file in a specific Windows folder. C program file is NVIDIA Corporation GPU licensing client config token. But the method depends on your setup. Follow the NVIDIA guides for this.
License activated, and then another reboot.
Usually, yes. Reboot the guest VM one last time. That should finalize the activation, and the vGPU should be fully functional within the VM.
And then we should have a GPU accelerated VM.
Yes. At that point, you probably want to enable RDP or install something like Parsec or Sunshine to actually remote into it and use that accelerated desktop.
Awesome. Okay, we've gone through the whole setup. It's detailed. Now, the big question, does it actually work well? What did the performance tests show?
Yeah, the source did some benchmarking, which is helpful. They used Cinebench 2024 in Blender. The test VMs had 8-pin Xeon vCPUs, 32 gigs of DDR5 RAM, and that L40S 12Q profile 12GB VRAM.
Okay. What did Cinebench say? Baseline first.
Right, baseline. The full L40S card, that's a 38GB card, so they used a 48Q profile for this test, in one VM scored 21,147 points. Pretty hefty.
Yeah, that's a solid score. Now, what happened when they split it 4 ways, using the 12Q profile on 4 VMs at once?
Okay, running Cinebench on all 4 simultaneously, the scores for each VM were down around 2,514 to 2,567 points.
Wow, okay, that's less than an eighth of the original score, roughly.
Yeah, it's a big drop when they're all hitting it hard at the same time.
Yeah.
Definitely shows the impact of sharing. But they did another test, ran Cinebench on just one of the 12Q VMs, while the other 3 were sitting idle.
Yeah.
The score for that single active VM jumped up to 15,133 points.
Ah, okay. Still not the full 21K, but way, way better than the 2.5K. So performance depends heavily on what the other vGPUs are doing.
Seems like it. If the physical GPU isn't being hammered by other VMs, a single vGPU can get a much larger share of the performance.
Interesting. What about Blender? Similar story.
Pretty much, yeah. Splitting the GPU meant lower performance per VM compared to running a similar profile alone. The monster benchmark scene was particularly tough. Performance dropped to maybe 8% for a shared VM compared to an equivalent unshared one.
Ouch. 8%.
Yeah. But they also saw something weird in Blender sometimes, like in the classroom scene. One VM would suddenly get a big performance boost, maybe double or triple the score of the slowest VM at that moment.
Any idea why? Like the scheduler giving one VM priority.
That was the guess. Could be the vGPU scheduler, could be something inherent in how the GPU handles certain loads. It wasn't always perfectly even distribution, second by second.
So summing up the performance side, it works. You can share the GPU, but expect a performance hit per VM, especially under heavy concurrent load. But it's still useful.
That's the takeaway. Yes, performance per VM drops when shared heavily. But for places prioritizing density, maximizing hardware use, the VDI farms, render farms, doing batch jobs, maybe certain AI training setups, the ability to share is still really valuable.
Right. It's about trade-offs. Raw single VM speed versus overall resource utilization and cost.
Exactly. Big enterprises often make that trade-off because consolidation and efficiency are key drivers for them.
Makes sense. Okay, really interesting stuff. Now, before we wrap up, let's take a moment to hear from our sponsor, Stonefly.
Right. Stonefly is known for being an innovator across a whole range of storage and data protection tech. We're talking SAN, NAS, S3, object-compatible storage. They cover a lot of ground. Plus backup and DR, cloud, AI, and security solutions.
And they have some pretty advanced features, right?
Oh, yeah. Things like immutable snapshots, crucial for ransomware protection, AES 256 encryption, replication options, smart tiering for storage costs, flash caching for speed, even specific ransomware volume protection. They actually hold a patent for their immutable and air-gapped repository tech.
Air-gapped? That's a big deal for security.
Huge. And they have a unified interface to manage everything, whether it's one node or like 128 nodes across different sites. They even got recognized by DCIG as one of the top 5 storage companies across SAN, NAS, and object storage.
Impressive. And they're growing.
Apparently booming. Over 100 job openings in tech roles right now. If you're interested, it's jobs@stonefly.com.
And they have a special offer running.
They do. 2 options, actually. You can get a $10 immutable and air-gapped backup setup. Or, get this, a 70-terabyte backup and DR appliance expandable up to 4 petabytes with ransomware protection built in for just $700.
Wow, $700 for a 70 TB DR appliance. That sounds incredibly low.
Yeah, that's a serious promotion. To find out more about that offer, contact sales at stonefly.com. And for general info on everything they do, check out stonefly.com. Again, sales at stonefly.com for questions. Definitely worth looking into if you need robust storage or data protection.
Okay, thanks for that. So, wrapping up our deep dive today on Proxmox vGPU. The big picture is, this is a really powerful way to share expensive GPU resources across VMs.
Yep, efficient, flexible, makes high-end GPUs more accessible for virtualization.
We saw there are performance trade-offs, especially when multiple VMs are hitting the GPU hard simultaneously. But for the right use cases, VDI, rendering, AI, where density or shared access is key, it's a very compelling technology.
Absolutely. It balances performance against that all-important resource utilization.
Now, we covered a ton of ground, lots of technical steps. If you need to go back over the setup details or the prerequisites, definitely check out the outline or the original source material.
And that brings us to the final thought for you, our listeners. Thinking about those performance dynamics, the sharing benefits versus the potential speed hit for individual VMs, where do you see the sweet spot? What specific workloads or scenarios in your world seem like the best fit for Proxmox vGPU?
Yeah, it's about that balance, isn't it? Peak speed for one versus good enough speed for many using the same hardware. Where does that line fall for you?
Something to mull over.
Definitely.
Yeah.
And as you're thinking about building out or optimizing these virtualized environments, keep solutions like Stoneflies in mind. Robust data protection and scalable infrastructure are always critical. You can find them at stonefly.com.
Thanks for tuning in to this deep dive.
We'll catch you next time.